This is Grace Everts, and I'm going to be showing how to find the velocity of a marble at the top of a loop. So the first thing we need to do is show what we know. So here's a drawing of the roller coaster, and this is a loop. And the height of the marble at the top of the loop will be 1.31 meters. As you can see, the mass will be 0.005 kilograms. As always, gravity is 9.8 meters per second squared. And in a last problem, we found the total energy, which is 0.097 joules. And we found that by adding the potential energy and the kinetic energy at the top, which is 0.1 joules total energy. And since the marble isn't moving at the top, joules for P, so that means the total energy would be 0.1 joules. So now this is no. We have potential at the top of the loop, and we will be the kinetic of the loop. And using the kinetic formula, we figure out the at the top. The equation of velocity when using G will be the square root of 2 times kinetic energy over. To find that kinetic energy, we will need to substitute the loop from total energy marble. Potential energy we'll need will be equal to mass of the marble's gravity times the height of marble. And then, when we're solving C, first we'll find the potential of the loop, so that's times gravity, which is 0.05 times 8 meters squared times 1.31 meters equal to 0.6. Since we know the potential energy, total energy, thing left will be the kinetic energy. So to feel subtract energy, the total energy, which will be 0.97 joules, 0.64 joules, which will result in 0.08 joules. And from that, we can use the equation. We will do 2 times 0.34 energy over the mass of the marble, 0.005 kilograms. Square root that, and you will find the velocity of the marble at the loop, 0.63 meters.